Hi. So this course, which is called Circuit Analysis, is the continuation of the Introduction to Electric Circuits. So we've got to repeat what we have done in Introduction to Electric Circuits and say what we're going to do next. Therefore, we might call this chapter as an introduction or a review of the previous subjects that we have done already. So this chapter has got two main uh, subtitles. One of them is analysis, the other one is the synthesis. Those two concepts are the basic concepts of engineering. So we've got to repeat those processes, analysis and synthesis, in the context of circuit analysis. So let's go into these subjects. What is analysis? First, analysis tells us what does a circuit do. So when you do analysis of a circuit, this tells us what the circuit does. So function of the circuit, job of the circuit is understood from the analysis. By analysis, apart from that, by analysis we could check whether a circuit transfers the given electrical signal input to the expected electrical signal output. So you can check a circuit whether it works properly or not by doing the analysis, because each circuit has an aim. Have we reached to that aim or not? So after the analysis we are going to say that the expected output is not coming out from the circuit, so there should be something wrong. It's not working properly. So you've got to check your circuit whether there's something wrong with it or not. So we could make that decisions by analysis. So let's go inside what is given at the beginning of an analysis. When you say we are going to analyze the circuit, so there should be something given to us. What is this given to us? Is circuit. Circuit is given means what? Is explained here. Elements types and their connections are given. So there are two things that definitely should be given to you. What type of elements are going to included in this circuit, and how those elements are connected to each other. So connection is also called topology. So these two information should be given when the circuit given to you. And then the input must also be given to you. So that means what we're going to, how we're going to, which energy source we're going to connect to this. This is source must be given to us. So these inputs, when we say the inputs given to you, so we've got to explain what these inputs are. So these inputs could be energy sources or could be information sources. What do we mean by energy sources? In order to run a circuit, you need energy. Without any energy, the circuit analysis means all the elements, current and voltages are zero. No need to analyze. But if there is an energy, then we can do the analysis, find all the elements, current and voltage. That means you can find the power of these elements, and then you can find the energy of these elements. Means you have found the energy distribution coming from the energy sources to your circuit elements. So what could be these energy sources? Independent sources, voltage or current sources, independent voltage and current sources. This could be a DC type or AC type. DC type is a constant, mathematically a constant Vt, It, and AC is a sinusoidal function. Mathematically it is a sinusoidal function. DC sources, we can give you some examples from the practice. batteries, accumulators, adapters which transfer AC to DC. These are all DC sources. It says here transistor requires DC sources to run in linear region. When you talk about the transistor is the fundamental element of electronics. So all electronic devices have got transistors in them. Since we are dealing with linear circuits, so in order to run these transistors in their linear region, we need these DC sources. DC sources is a group of source and which are very important. So they are very common. You could see all these DC sources for your telephones, for example. You've got batteries, and laptops have got batteries, and all the other devices we are saying, these devices, DC sources are inside the device. So that means you've got to use the adapters. These adapters are inside the electronic devices. And they have got a DC output, so they use a DC output inside the equipment, so you might not see it. For laptops and telephones, you could see these elements, so that's batteries, accumulators. So another energy source is AC, alternate current sources. So in every house we've got this energy source. The other hand of this energy source are the energy centrals. So that means it could be hydraulic and thermic electrical sources. For example, in Turkey, this energy comes from Keban, hydraulic energy source. The other end of these lines is our houses. So that means the energy from here transferred to our houses comes to these mains in our houses. These are AC sources. Mathematically, it is like this: Vt is equal A times cos omega t. Omega is related with frequency. We could see all these functions later in detail. So these are our mains at home and wall sockets at home. So these are the AC sources. Another energy source, we are talking about what is given with a circuit. Another energy source is the initial conditions of the capacitor and capacitors and the inductors. Capacitor voltage, inductor currents are the initial conditions. These initial conditions are also the energy sources. So we are giving here you in practice the common energy sources. We said another sources are independent source we are talking about. One group is the energy sources, the other group the information sources. What are those sources? Inputs could be electrical signals which store information. What is information? Audio. When we are talking, that's audio signal. This is information. Text is also an information. Stores information in it. Image stores information. Video stores information in it. These informations are processed or stored or transmitted or received, so you can process all these information sources. This is what is happening in practice. So when you come to electronics, signal transformation elements are required. So these information sources should be transferred to electrical quantities, because we are going to use this information, process it or store it or transmit it, receive it. All these operations are going to be done in electrical world. So these energy sources, which is different forms, that is text, image, video, these are different forms of information sources. So we've got to transfer these information sources to electrical sources. This electrical source is the information sources. How we could do that? Signal transformation elements are required. For example, for the audio signals, this element is microphone. Microphone transforms the audio signals to electrical signals. So this that's the transformation. So you can process these electrical signals within electrical equipments, and then the output of your electrical equipment is an electrical signal. You've got to transfer this electrical information included signal to the output, to the practical world, by using that speakers in Turkish hoparlors. So that means you are transferring your electrical information included signals to the accustomed information. That's audio. So input signal, physically independent source. That's the input signal. Mathematically, a function of time. This could be a VT or IT, independent voltage source or current source. This is the sum of the sinusoidal functions. Any function of time could be written as the sum of the sinusoidal functions, Fourier series. And this summation fits to linearity. You see, the linear circuits, if you've got more than one sources within the system, you can find the solution for each source. When you add them up, you can find the solution when all of these independent sources are included in your circuit. That's linearity. So it fits to that linearity because we are going to see the summation of the sinusoidal functions as any function could be written in this form. So what I mentioned here, a bit long, I know it is a bit long, that explanation, but we are talking about how the circuit given to us. We said there should, first of all, element types and their connection should be given. Then input must also be given. This input is going to be independent sources, could be current and voltage source. What type of independent sources are there? Energy sources could be, or information sources could be. Let's give you a practical example from the information for the information sources. Consider a TV equipment. The antenna output, antenna transfers the electrical quantity, electromagnetic signals to the electrical signals as an input our TV set. That signal is an information source for the TV source. We connect the TV set to the power source, that is energy source. So you plug in your TV to the wall, that means you did the energy source connection, and you connect the antenna output to your TV, that means you applied an information source to your TV. So we are talking about these two inputs, different type of inputs that we could use in electrical devices. So these sources should also be given to you, we are saying, by when the circuit is given means that. So what we have done here, we said what analysis is. In order to do the analysis, what is given to us is this. We just explained that. Then what we do by the analysis is explained here. What is found is the output of the circuit. Could be of an element voltage or current, or could be more than one element's current and voltages. For the TV sets, for example, screen inputs, speakers inputs, USB inputs, these are all the information included electrical signals as an output. So we are going to find or figure out or calculate these outputs while we are doing the analysis. Or what we have done is analysis. Finding all these elements current and voltages, output elements current and voltages means you have done the analysis. This is what analysis is. It is important. So we said before that we explained what is the use of it, what is analysis explained here. Now how we are going to do analysis is the next frame here. There are three tools. One of them you could do the analysis in lab. The other one you can use the software tools such as Proteus that you have seen it in Circuit Lab as a course. That means 2202 software tools, and then mathematics. So there are three tools that we could use to do the analysis. While we use the mathematics, up to now we have used two different mathematical tools. One of them is linear algebra, the other one is ordinary differential equations. These are the different courses that you have taken already. The circuit elements classification analysis. There is a relation between the circuit and circuit elements or circuit classifications. That means resistive circuits or energy storage elements included circuits, two groups of circuits. For different type of circuits, we use different mathematical tools. That's why there's a relation between element classification and analyze. So let's start from the beginning. Nonlinear circuits, not in this course, but in electronics course. You're going to see these nonlinear element circuits. These, so I'll give you an example. Diode, for example, is a nonlinear element. Diode included circuits are not examined in this course. You will be examining this in electronic course. We are only analyzing the linear circuits here. In circuit analysis, introduction to electric circuits, we do the analysis of linear circuits only. In lab, what we do, we use a breadboard. You have seen that breadboard in introduction to electronic circuits lab. And we put the circuit elements on the breadboard, do the connections, that means topology, and then apply the inputs by using the function generator. Function generator you will be using in the lab for in electronic circuits course. It produces all the inputs that you required. It could be a DC input or AC input, whatever it is applied by the function generator. Pulse input could also be done. Outputs are going to be measured by using the multimeters, ammeters, multimeters. You can measure current and voltage, or you could observe these electrical signals by an oscilloscope. This device shows you change of this signal, electrical signal, in terms of time. What it's changing versus time is this device shows you that. We haven't used that device yet, but you are going to use this device in electronics. The another analysis tool was, we already said, Proteus. Proteus, we have seen this. In Proteus, how we do the analysis, you've got to draw the schematic first, use the primitive modeling elements. These are the elements that we use in theory. And then we're going to use inputs, generators, simulator primitives, which are the subjects in this Proteus tool. And then the outputs, for the outputs, the tool that we are going to use in Proteus is the voltage current probes. So instead of this multimeter in here in the lab, we will be using probes in Proteus tool. Or we could use graphs as well. So graphs shows you the electrical signals changes with respect to time. So oscilloscope output is the same as the graph that we see in Proteus. So these are the two tools that we have done and use up to now. And we also use the third tool, which is mathematics. So we are going to divide this mathematics in two by grouping the linear circuits, resistive circuits, and energy elements included resistive circuits. So these resistive circuits do not have L and C type of elements in it, but it only includes resistors, dependent sources. Inputs could be DC, AC sources. So the mathematics that we use in order to solve these, in order to analyze this circuit, is linear equations. By hand, you've got to do it, or you could use MATLAB as a tool to find a solution of these linear equations. The other group, circuit group, is energy stored elements included circuits, apart from the in addition to the resistive elements. And when these inductors and capacitors comes in the definition relation of these elements, we've got derivative. Because of the derivative, the equations that we are going to write are going to be ordinary differential equations. So for those type of circuit analysis, we use the ordinary differential equation. So two different tools, algebraic equations, linear equations, and the ordinary differential equations are those two tools that we use mathematically in order to analyze a circuit. So what we are talking about, how we do the analysis, we have seen the tools, and we have seen the basic tool, that mathematics here as well. What are the methods that we use in the analysis? Calculation of the elements current and voltages. That's one type of analysis group. The other one is voltage current calculation for only outputs. If you do the calculation for only the outputs, not all the elements and current and voltages, but just for one or two elements current and voltage calculations, this is the other type of analysis. These two type of analysis we have already seen. Just repeating what we have done already. So if you are using all the elements, if you are using the analysis method in order to calculate all the elements current and voltages, so there is a classical method. You're going to write to any equations. Any is the number of elements. To any unknowns are each element has got current and voltage. Therefore, to any unknowns, all the elements current and voltages. So calculation of these unknowns, we need to write to any equations. That's classical method. To any equations, to any unknowns. You can do that by solving the linear equations. Another method, we said mesh current method. In this case, you use less number of equations, NE minus ND plus 1 equations, plus the supplementary equations, or the other method, node voltage method, ND minus 1 equations plus the supplementary equations. We also use in the analysis, in the methods, equivalent circuits, serially parallel connected elements, and source transformation. Those two equivalencies helps us to reduce the number of equations that we are going to write here. So all these analysis methods that we set here is for the calculation of the elements current and voltages. But from time to time we might need to find only the output elements current and voltages. Then could be one or more than one outputs. So in the previous one, we are doing the analysis we said for the elements current and voltages, and we used the Thevenin-Norton equivalent circuits in the Introduction to Electric Circuits course in order to find one of the elements current and voltages. In this course, we will be examining two ports elements in order to find the outputs of a circuit. So that is this analysis, and the other one time domain analysis. What is done, what will be done. So done, what we have already done in Introduction to Electric Circuits, time domain analysis, we have done it, and will be done in this circuit, that means circuit analysis course, 3201, frequency domain analysis and S domain analysis. So we are introducing two new domains now. One of them is frequency domain and the other one is the S domain analysis. We will be examining those. So let's see it now. Introduction to Electric Circuits, EE 2201. Domain, time domain. Circuit elements, resistive elements. Energy storage element included circuits. For these circuits, our equations are linear algebraic equations. And what are those terms are explained here. So let's say xt is all the elements current and voltages, and ut is the inputs or the independent sources. A and B matrices includes the parameters that we have seen in the definition relation of the elements. So these are linear algebraic equations in order to analyze these circuits in time domain. If resistive circuit elements plus the energy storage elements are included, so that means these new elements introduced, then our equations are going to be differential equations. So derivative of the unknowns are going to be seen in the equations. This is the state equation here, that xt is the state variables. State variables are the inductors currents, and capacitors voltages are the state variables. We're going to find the state variables from these state equations, which is a ordinary differential equation. Once we have found these state variables, then we can calculate all the elements current and voltages, and both those equations are called system equations. Solution of these linear algebraic equations, the ordinary differential equations, are going to be in this form: homogeneous solution and plus the particular solution gives the general solution. And we have also seen in Introduction to Electric Circuits natural solution and the forced solution. Addition of those two also gives you the general solution, which are the same. So I explained all those. So this is all we have done. We have done this in time domain. So what we are going to do in this circuit, which is this one, now circuit analysis 3201, domain, frequency domain, and S domain. In frequency domain, all linear circuits. Now, in the previous one, there are two groups. In here, we've got all the elements included. That means linear circuits, all of them. Linear elements included, all linear circuits. The equations that we are going to write in frequency domain is going to be in this form. That is an algebraic equation, but in this time the unknowns are a new subject comes in, which is called phasor. All the elements current and voltages phasors that we are going to calculate, these phasors are going to be complex numbers. Once we found this complex number, we are going to transfer it to time domain. From this complex number, we are going to find time domain Vt and It, all the elements current and voltages. So a transformation is needed here. At the beginning, we are going to transfer the time domain independent sources to frequency domain independent sources, and then we are going to transfer the definition relation of time domain definition relation to the frequency domain definition relation. At the end, we are going to end up with these complex numbers as solutions. There are limitations in this domain. What is this limitations? Input is sinusoidal only. For different independent source, we cannot use that frequency domain. We could use the frequency domain only for the sinusoidal independent sources. Particular solutions only is going to be found. Not all the solution, only the particular solution, but still acceptable. We are going to explain it. No stability decision in this domain. Requires simple transformation from time to omega domain, frequency domain, that's omega, and from omega time unknowns are elements of voltage, current, and phasors, which is a complex number that we mentioned here. The other domain, which is called the S domain, we do the Laplace transform, so this is true for all the linear circuits, and the equations are going to be linear algebraic equations, but independent variable is not t here but s. So we are going to find the solution in S domain and then transfer this solution to the time domain. So if we compare this now, we are going to find all the solutions. In here only the particular solution, in here all the solution. We can say whether the circuit is stable or not in this domain, but we cannot say it in omega domain. And we've got to do the transformation from time domain to S domain. At the end, we were going to find that excesses in S domain. We've got to transfer these functions to the time domain. These transformations are required in this domain. So this is what we are going to do. And what we are going to do in synthesis. So let's remember what synthesis is first. Build up a circuit which does what is required. Synthesis means build up a circuit which does what is required. So you need something, transfer an electrical signal to another electrical signal. This is what is required. So you're going to set up a circuit which does this. Then when you set up this circuit, that is synthesis. Analysis could be done without math, but synthesis requires math. That is why the math is important. Synthesis requires math. What is given in the synthesis? Input must be given, and required output should also be given. That means the box, input and output is known, but what is inside is not known. That means what is to be found? Element types and their connections. So you're going to find a circuit here. Then it is called design or synthesis. In theory we call it synthesis. In practice we call it design. So in this course what we are going to do, we are going to do the filter design by using the passive elements and by using the active elements. Active elements are going to be op-amp included elements, and passive elements are RLC elements. So we are going to see part of this filter design. There is additionally a selective course for filter design. If you want to, you can choose that course as well. That is the end of this introduction or review, let's say.